to for the session.
ठीक है ठीक है वो चल रहा है नहीं ठीक है this is fine. So I think I'm between the session is between lunch, right? So myself and lunch, right? So I'll try to make sure that this is interesting. Everybody gets the well use of the time. So we'll spend probably like an hour or so. We'll try to understand because this session will help you to get an understanding of both the concepts, AI, ML, where my expertise is, and also the smart drives, EV systems, how to use AI in battery systems, and so on. So I'll try to give a brief understanding of that. So over the next few days, you will get more deeper into specifics of those technology. Probably you'll be talking on more on battery systems. There are sessions I saw professors from NITs, they're going to talk on drives and so on. And why why electrical engineering is very, very close to my heart is because I did my diploma in electrical engineering. I did my BTech in electrical engineering, but unfortunately I have moved out of it, you know, but I've hardcore at heart electrical engineer, and thanks for doing such kind of a sessions because it will bring back my memories about a lot of things. So I did a lot of research. In fact, I'm doing my doctorate in business administration, specifics on AI ethics, privacy, and so on. So those are my topics. But I also did a little research on how how that is applicable to electrical systems, specifically the EVs and the ethics and biases and fairnesses which comes from the use of technology, specifically AI, right? So these are some of the topics which I would like to talk. Firstly, I would like to give a background of AI because this is very interesting, right? AI is not very new. It is there for many, many years. If you ask me when it actually started, 1950s, that's when the term of AI was initially started. Artificial intelligence as a concept was given during those days. So primarily, use of AI was trying to see like how I can make a machine, a computer now, make the work of humans. So that is as simple as it. Like, can I use machines take the work of humans so that humans can be putting their effort in much more important things, right? Now, Professor Satyanarayana was talking about jobs and losing of jobs and things like that. It's a very essential topic, right? And if you ask me, when I speak to students, they also have this kind of a notion that when AI is taking over the world, AI is taking over a lot of jobs, will it will be obsolete. Should I study electrical engineering or not? Should I study computer science? Should I study electronics or not? So these are all our bigger questions. But to me, I would say that AI, as I said, it is there for very, very long years. It's not new. And it is going to stay for a longer time also. And one very important thing which, if you observed, Professor was talking, was on augmenting your technology with AI. How do we complement the knowledge, whatever we have in electrical systems, drives, or power systems, SCADA controllers, or whatever it is? How do we augment that knowledge with the use of AI? So if we are able to do it in any walks of life we are in, we will be able to propel our journey much faster. So if you go to our history, early 1950s, the early use of AI started, where people started that, can I use some logics, can I use some reusable automations so that I can change the way in which machines work, primarily computers, so that they can do our work. It was primarily about automating systems. It did not work. It went into an AI winter around 75s and so on, is because there was not enough amount of data. Now, what about data? If you can talk about electrical systems, we have huge power lines, power systems available. A lot of data is being collected in each and every circuitry, right? So that data availability was not there in early years. The next AI hype came into around 1980s, 1990s, where the data was available, but the second thing which was not available was the compute. Now I have, now if you see, thanks to a lot of systems, now we have cloud computing, you might have heard of it, where we can, with a click of a button, I can spin up a lot of compute systems where they will be able to take data and do the computation. The second AI winter happened where the computation was a problem. The data was available, but the computation was problem. How do I take this large volume of data, identify some patterns, come up with some kind of a insight? So that was a challenge. Now we are in the third phase. Now we are seeing the chat GPT era, right? Every one of us, even my kid uses chat GPT, right? So he's like in the sixth grade. If I, to tell a story, there was one assignment for Dasara, so holidays. So he has to prepare like, how is Dasara celebrated in different parts of India. He is like, when, if you take a 10-year back, they used to go to Google. Nowadays, kids are going to chat GPT, right? And I'm sure you all can relate, and we all also use that extensively. Extensively for us, AI is that kind of a mode. But if you can expand the horizon, AI is being used in each and every industry, each and every area. So today we'll try to understand from from an electrical engineering perspective, specifically on the drives. It could be different EV related technology, and some of the grid related systems also. We'll try to see what are the areas where we are seeing that there is an involvement of AI. And one advantage is that um, if you do some projects, because I see that a lot of faculties, some PhD scholars maybe, one advantage we are seeing is there is a lot of funding coming up from both AICTC, UGC. There is also a private funding coming up for people who are interested in doing research or research projects in universities, combination of universities with academia, universities along with industry. So there are a lot of focus towards doing research projects. So if you're doing some research projects with the technology in use, maybe you might be working on, maybe drives, I would say, right? How does the drives work, and how to optimize the usage of the drives? Can we have integrated electronics which can be acting as a sensors for the drives, so that now that data can be collected, and so on, right? Um, all right. So the technology is working. This is how it. So with that knowledge, we will try to take one step back on AI ML. Now there's AI ML and DL and generative AI and a lot of other new technologies, toolings are there. So to understand the background, right? Artificial intelligence, as the name suggests, it's a concept. It's not again a technology. It's a concept in which we are trying to say like how I can use the latest technologies. There are some algorithms which we can use, which can help to reduce the work of humans, where we can automate a lot of things. Those are like rule engines. Basically, automation systems can be simplified rule engines. I can write rules which requires specialized knowledge. If I say like a very specialized knowledge in power systems, and they are very highly skilled in understanding power systems, how the transmission distribution lines work, how are the technologies involved in those things, right? So they can come and say that these are the rules, and we can kind of write those rules and create an AI system. That's the first step. Now, even if I take the example of power system, there's a huge volume of interconnected devices are there. A lot of systems are there. It is very difficult for us, for a human, even he is an expert, for them to write the rules. So the second step is machine learning, where machine learning, what it does is it takes a lot of algorithms. There are a lot of suite of algorithms. Again, I would recommend you guys to after this FDP, try to identify some data points, some algorithms which can help you in your research. Okay, so there are like hundreds of algorithms which are there, but the primary purpose of the algorithm is, instead of a human doing the research, giving the idea like this is how the rule should be, the algorithms will be able to identify those rules. There are patterns, hidden patterns within the data. Can I collect a lot of data from power systems? Yes, I can do. From SCADA controllers, from different drives, transformer systems, transmission lines, and so on. So there is a huge amount of data which can be collected. Once I collect the data, how do I identify patterns within the data and can do some kind of measurements with respect to optimization of power transmission or optimizations of utilization of power and so on. That can be done by the machine learning system. So AI and ML, typically they are used in the conjunction, but AI is like a broad concept. ML is a technology which uses some of the algorithms where humans cannot define the rules by looking at the data, so that ML algorithms will help to write those rules. Then coming to deep learning is where we are seeing that there is a lot of penetration towards unstructured information we are seeing right now. Of course, all our electrical systems, we come into a category called as unstructured or semi-structured nature, because you can connect IoT systems which can be sensor information, it can be gyroscope, it can be proximity sensors, it can be any different type of sensors connected to the machinery, and they will help us to provide both structured as well as unstructured information. So deep learning is one subfield of machine learning, which will help us to act on the unstructured data. Now we are seeing all the images, videos, chat information which we are seeing from the chat GPT like of applications. They're all unstructured in nature. Right? And pretty much we are also seeing that a lot of data which we collect from all these sensors and so on will also be coming into unstructured or semi-structured nature. They have some kind of a structure, they come into the semi-structured category. So that is the brief about these toolings. What we'll do is we'll spend some time understanding different technologies. Specifically, I'll be talking on the EVs, what are the areas where we are using AI and ML in the sector. As we go deeper, I want you guys to write down your expertise areas, right? Probably you might be interested, for example, talking about smart vehicles, advancements in smart vehicles. You might be interested on how is predictive maintenance working in smart vehicles. How the predictive maintenance can go as deeper as possible, but let us try to understand different areas which we are using AI in smart vehicles. First one is autonomous driving. It is the ability to autonomously navigate, maneuver, right? We are seeing a lot of companies right now, the EVs equipped with autonomous driving systems. The Teslas of the world are already driving in many of the developed countries. They are also trying to venture into India, but we know like how chaotic Indian roads would be. It will be very difficult for an autonomous vehicle to understand the nuances of Indian road conditions. Probably it might needs to learn some bad language also for for maneuvering on the Indian roads. But just to understand, right? So when a vehicle has to completely equipped with decision making, we have a lot of electrical sensors on this. If you are really interested to understand like how EVs, specifically the smart vehicles, right, autonomous vehicles work, you have LiDAR sensors, you have proximity sensors, you have different pedestrian mapping sensors, we have GPS connected systems. All those information is going and providing a nudge to either accelerate or brake, right? A car has to move, so we need to either say like accelerate or do a braking. So all those information is now trying to give information to those systems. Of course, it also helps you to navigate the steering controls, and all those things will also play. But that itself is a deep research area, right? Each and every topic. Now, the second one is the predictive maintenance. Now, this is where even 10 years back we have started. 10, 15 years back also, early 2010s, we were using predictive maintenance for many of the electrical systems. For example, you have a large workshop, right? Maybe a large manufacturing workshop, say like manufacturing cars. So this is a huge production line which is there, and you have different electrical connected systems. They're manufacturing cars, and all these different systems can be equipped with IoT sensors now, right? Sensors like the gyroscopes, the wear and tear sensors, the proximity sense, not the proximity, the what do you call it, turbulence sensors. So it basically identifies the turbulence of the lathe machine, which can cut the car parts and so on, and do the maintenance and so on. So even 10, 15 years back, predictive maintenance came into play, where how do we identify which component is going bad. So but there is a huge production line, and I can say that machine number 58, please go and change the lubricant. And there is a supervisor is there. And previously the job used to be so tedious, because the supervisor's everyday job is just take a checklist, go and check the lubricant, viscosity. It can check the temperature of the lubricant, then the turbulence, and multiple other things have to be manually checked. But when the preventive maintenance came into picture, we are having these sensors which can check a lot of these things. I can check the turbulence of the machine. I can check the uh, viscosity of the lubricant fluid, the temperature of the lubricant fluid, and based on all those things, I can say that can the lubricant has to be changed or not. Right? So that is called as the preventive maintenance, where we are seeing this all automated AI algorithms will be fed data in real time. Now I know that this machine in 2 weeks we have to change the nuts and bolts or some kind of parts, because they are already getting into the state of wear and tear. And how do you know that those particular parts are getting wear and tear? Is that we already have a lot of data in the past. These sensors first are being fed into the machines to capture all these anomalies. Anomaly is nothing but it's an occurrence where the machine went bad, right? But how did it went bad? Because of these A, B, C, D reasons, it went bad. So all these systems, especially the electrical systems, were fit with all the sensors which can capture the information. So first cut is that I need to capture information. I need to know what is going bad. And then from there, we feed that information to algorithms to identify those anomalies, saying that on which condition did this machine fail. Then it will come up with the action saying that because of the lubricant was beyond this temperature, because this nut and bolt was loose, or the turbulence went it so and so. So that's where the preventive maintenance is coming. Now, what we are seeing is that is coming into autonomous vehicles. Can it automatically say that because my brake pads are going bad, can I change my air filter? Of course, you will see in a lot of the newer vehicles, you get these kind of indications saying that you need to change your air filter and so on. How did it get to know? Is because the cars, the newer cars are uh, being generated with the electrical monitoring systems, which are pre-trained on this kind of conditions, so that it can identify when to change a specific air filter or certain kind of a part or machine and so on. And when you see it advanced EV levels, we will see all these kind of things coming together. So the preventive maintenance is that. So enhanced safety is basically improving the overall driving experience, and this is where the technologies like ADAS and things comes into play, right? How do I identify pedestrians? How do I identify overspeeding? How do I identify automatic braking mechanisms and so on will come as the advanced safety mechanism. And then real-time data analysis, this is which helps the support system of all the other applications. Now, as I said, right, the systems are now equipped with different sensors. Now you will be able to feed that real-time information. Now, when we are talking about a moving vehicle, how does it capture? How does it transfer and transfer information? Is it like a centralized transfer, or is it like a cloud-based transfer? So these are all bigger questions. Should I store that information for some duration and then transfer it at a later point at equal intervals, or I do a real-time transfer of information? And how do I transfer? Where do I transfer? So there is research on that also, right? How mechanism of transferring the data. A large volume storage of data is possible. That is known because we can put multiple sensors and we can capture data. Now, I get the data from my vehicle, but how do I transfer? Again, there is a lot of research happening on that front, like what are the optimal mechanisms of transferring? Should I need to connect to to a connected gateways or grids every time, or should it be on a timely manner, like maybe weekly or monthly and so on. So that is where the real-time data analysis come into play. Another important, a lot of work happening, especially in the EV systems, is EVs are the most important part is the battery, right? And the battery and the control system around that. Like, how do I maintain, battery and the control system, the cooling mechanism, and all those things? So, if you're getting into research on the EV side, this space is used the most, right? Where, for example, these are some of the points where we see that there is a tremendous amount of use of AI. Is, for example, how do you estimate the state of charge of a battery? State of charge talks about the current charge discharge levels, and how much it can run for a specific charge, and how is the overall health of the battery over the time. So that talks about the state of charge estimation. Again, battery health monitoring and diagnostics. This also talks about uh, the related things, right? So when you talk about battery, it's all about, like, how much time it takes for charging, discharging, and then how much runway it will give for one charge. And then overall, through the life of the battery, you see that there is a certain dip in the performance and so on. And then what is it causing for the dip in the performance and so on. All those things are monitored in the battery health monitoring systems. Optimal charging and discharging strategies. This is also important. Like, uh, it tries to identify that what is the optimal way of charging and discharging the battery, how much time we have to charge. We have created autonomous trip systems which can, after the battery gets charged to its optimal level, it can get disconnected so that it doesn't go and wear the battery with overcharging, such kind of systems. Smart thermal management is again, the battery has to be in a such kind of an environment where it gives a proper cooling mechanism. If it cooling mechanism is not there, what happens is the battery gets discharged quite faster because of the thermal heat. And also, uh, the life of the battery would also degrade because this the battery gets overheated uh, based on the conditions and so on. So there is again a research specifically on this topic, like, how do you design batteries for different conditions? Indian battery conditions are completely different from that of a company like Tesla manufacturing a battery for US kind of uh, temperature conditions. Driving conditions is completely different from that of tropical conditions like India. So there is again a huge research on how do I design cooling systems around batteries, or extended cooling systems, which will help for the battery's performance to be much better. And again, AI is being used to simulate those scenarios, different scenarios. You have enhanced reliability and longevity of the batteries. This is again talking about considering all those things, like how do I maintain the state of charge, how do I maintain the battery performance, the thermal cooling systems and all, which will help to increase the life of the batteries. This is again in specifically in the EV controls, and that specifically on the drive, AI based drive controls on the machine, right? We are seeing a lot of this coming into the play. Now all the new cars are equipped with these kind of new things. Specifically, if you take adaptive cruise control or automated lane keeping, traffic prediction and avoidance. Traffic prediction is one of the interesting project also. I remember around 2015 or so, when we were doing research on uh, one of the car manufacturing company, and this was one of the project which we did. Now, how do we determine traffic, and how do we do automated traffic uh, avoidance? Right? You see that in Audi or some car. I have an example for that. They already have that in place to identifying traffic conditions and traffic management. So all this is about how do you make the vehicle performance improved. You can have the adaptive cruise control. You can have automated lane keeping, identifying whether we are switching lanes or properly being in the lane or not, following the driving rules and conditions or not. All those things are tracked within the vehicle. The traffic prediction, especially at that time, what we did is, once we have the traffic signal had cameras which can look at the vehicle, number of vehicles. So it was a very naive idea. This was back 10, 15 years back. Then we were trying to identify like how many vehicles are there, and based on that, we try to determine the traffic, right? Whether there is a traffic or not, and based on that, automatically the signals used to coordinate, which can switch the signal timing. Sometimes what happens is no vehicle, but the light is there for 30 seconds for no reason, right? So we at that time we designed the system that looking at the vehicles, we can identify the object detection, basically the vehicle object detection, and from that I can know from the all four angles whether there are vehicles or not. Based on that, automatically the signal will switch on and off. But that is now embedded in the car. Now, if a car knows that there is traffic in Gulbarga and or Kalburagi, and it should not take that route, probably take a detour, right? Now, such kind of technology is coming in where it is integrated with Google Maps server systems, which can send signals, and then based on that, it can take um, additional conditions. Coming to emergency braking assistance, this is again within the car, the ADAS systems which are developed using the mechanical electrical signals will help us to identify automated braking mechanisms, which can help better car production, right? From a safety standards also, we are seeing all the new cars come up with ADAS controls, which are with emergency braking. And customizable driver modes are also there. Now we know that we have manual driver modes, right? If you have driven any good recent cars, you can switch it to eco mode, you can switch it to sports mode, and so on. Now, is there a way the car can identify, depending upon the condition of the road, it can switch between the modes? That's where the automated driving control comes in. So I am going on a hill drive. Regularly, I drive in regular traffic. I've set it to one mode, but it is now automatically understanding that my road conditions are normal. It is a regular traffic mode, city driving, so I need to switch to the eco mode. And if at all I'm going for a hilly ride, it understands the road conditions, probably bumpy ride, and probably it has to switch on to the sports mode so that it can have more power and more torque, right? So all those things are like coming into the customizable driving modes and capabilities. Another interesting related area is the EV propulsion and charging infrastructure, and this is very essential for a country like India to prosper in the space of EVs, right? And we are also seeing that there are again different governments, both central and state governments, are trying to put efforts with the collaboration with the private entities to come up with the charging infrastructure for EVs. If I want more EVs to drive in the city or even in the rural areas, we need to have this kind of a charging infrastructure which can provide a lot of capabilities. So that's but the charging infrastructure should also come up with a lot of uh, ecosystems. Probably there will be discussions on this, like how do you provide this dynamic charging infrastructure management where they are interconnected with different grid systems, local grid systems can be interconnected with these charging ecosystems. And we can also have the vehicle to grid integration also, especially in developed countries. We are seeing that uh, if my battery, my drives are such a way that it can recharge the batteries, because during the drive time, it can recharge the batteries. And when these cars get connected to the grid or the charging stations, it's not like the grid is feeding energy to the vehicles, but they can do a reverse uh, reverse this one also, but reverse pumping of energy also. Regenerative braking, yes, the concept is that. So what happens is, like, now we're seeing that such kind of systems are there, but for that we need to have the infrastructure. We have to have the regenerative braking capabilities to have a reverse pumping of energy and so on. But that gives a lot of advantage to the owners of such kind of EVs, because it's not only saving costs, but it is also helping to earn from reverse pumping of energy to the grids. And that happens when there is a peak load of energy. For example, in certain parts of the time of the day or during some particular season, there is a peak load where we do not have enough power capacity. Such kind of times we get an increased spike in loads, and in those times we could see that these EVs can pump in energy back to the grids, and which will help them and earn more money also. Right, so that's the vehicle to grid integration capabilities. This also helps in to see like whether, and again this is dynamic in nature, right? So I do not know where the peak load time is. Can we create systems? Again, this is still in a research. Can we create systems which can identify peak loads, can give real-time information to EV owners to pump back energy, right? So such systems are not there, but we are going to see such kind of automations happening in the future. Again, they are AI driven. How do I know that now is the time to pump back energy, right? Maybe such kind of mechanisms will be created in the future where we'll see that it will do an intelligent notification for the EV owners. Fast charging compatibility is also there, where it is also helping to improve ranges and charging times. So this is also there, like again linked back to our battery performance and battery management also. How do I create entire battery ecosystem in which there is a capability of fast charging, fast discharging, and which will help us to improve the entire charging infrastructure. Another, of course, EVs continuing is the concept of smart grids. Again, we are seeing there's a lot of work happening in this space. If you are following up, a lot of AI related stuff is happening in the smart grids. Like how do I make a grid smarter for both transmission and distribution systems? How do we identify demand response and load forecasting? Load forecasting is very essential because sometimes it's high, sometimes it's low. But if I know like when it will be high or low, based on that, I can tune up systems. Like we do have a lot of external systems. For example, I need to go for external renewable power or buying of a power and things like that. All those things can be decided by load forecasting, and we do see that early applications of AI/ML happened in this area, right? Where we are seeing that how do we do a demand forecasting or load forecasting of grids, interconnected grids, so that grids can distribute energy in much planned manner, right? So we know like where there is demand, and those places we could have a distribution. And grid stability and reliability is also important. This talks about whether the grids are able to uh, uh, you know uh, cater to the power requirements of different, especially this is very essential for industrial areas, right? So grid stability and reliability very essential for industrial areas where there is a lot of production happening. So it needs to cater to those requirements. Specifically, we see that because of that only we'll see that there will be some power cuts in the rural villages, and that is one of the reason for that. If we can automatically create demand and supply forecasting, and then can automatically switch between those industrial corridors or rural areas, that will help us to create a very stable grid ecosystem. Distributed energy resource management is also complying to the grid stability. Is like, once I know that this is where the demand and forecast is, how do I ensure that I can distribute that to a different sources of energy? We are working on renewable energy. We're working on different existing current energies like thermal or hydro and other kind of. Now we are also seeing the EV ecosystems also coming up. But how do I manage those all different systems in a kind of distributed energy resource management, which will help us to have a very stable grid also. Optimizing energy use and cost. This is also essential because uh, it's a trade-off, right? We need electricity, but at a minimal cost. So we need such kind of a trade-off has to be utilized, and at a very big level, if you are seeing, if I want to start a thermal or initiate the generation of thermal power, right, or a hydropower. Hydropower again depend upon the availability of water resources and so on. But that also decision of starting the hydropower. Imagine we have a catchment area where we had collected a lot of water. Now I to use it hydropower thermal. So the decision making is also very, very critical. And nowadays we are seeing that at a very high level, not only at a regional level, at a very high level, we are seeing that these decision makings are being done with the help of AI and assisted. It's not like AI will turn on the hydropower generation and all, but it gives us an assisted information, like where is the power distribution more, is it profitable enough for running a thermal generation for an extended period of time. Should I switch back to a hydropower, or should I buy energy from somebody else rather than uh, generating it locally? So all these things matters, because these decisions again at a higher level, but need to be have a very, very strong grounded data information. And that's where the optimized use of energy use and cost is used at a very high level. Again, the last point which we covered in the previous one is like, how do you create the EV infrastructure which can have the grid intelligence? Like, can I pull energy from an EV infrastructure, or can I push energy to the EV infrastructure, and which is cost effective, right? If it is cost effective during the peak period, it's better to get the energy from the EV systems. We have that regenerative power and regenerative braking capabilities which can feed in energy to the grids. So that's the last point. Now, all these are very, very good things, but electrical engineers, there are certain challenges and opportunities also. Now, when we are dealing with the data, it is very, very critical to keep a lot of things into constraints. So how do you maintain data privacy and security concerns? So this is where my PhD research is on, like how do you do data privacy and security in multiple systems, while my specialization is on banking side, but this kind of philosophy is applied to any area of engineering, right? Data privacy concerns are very, very essential. Again, security concerns, utilization of data, reliable use of data, responsible use of data. These are some of the industry patterns which are being used. So those patterns have to be used during the uh, ingestion of the data, during the transformation of the data, and during the consumption of the data. Ingestion talks about how do I connect different systems via sensors or grid systems and so on, which can generate data. Like who is generating data, what data it is generating, is it storable, storable to what security level? All those things are very, very essential, so that while the generation of data is happening, then and there you will track all these metrics. While we are transforming the data, that means that for making some kind of a decision making, either it can be demand forecasting, or it can be any other decision making, we need to ensure that it is also following the same data privacy norms. So while that is a challenge, and the opportunity side is like, how do you create those secure systems? There are different types of protocols. Every industry area is having secure data use protocols. So this is also one other interesting thing which you can take as a note is, can we identify what are the different security protocols or data use protocols for energy systems? Can be EV systems, power systems, or drives. So what are these security protocols? What type of security should be utilized? And what are the industry standards for doing that kind of a secured data use? That is also one interesting research area. A lot of people can do that. Again, regulatory frameworks and standards, again, different regulatory bodies are there which will provide a lot of regulatory norms of usage of data, responsible use of data, and industry standards are there, like how do you use this data in an interchangeable manner. The standards are essential because every system, not only company, every system has to create the data in some kind of a common format, right? So if I say like my my company is there, Sitaram Microsystems, and then it is creating applications and it uses its own standard format. And some other company like, you know, uh, say like Professor Amar's company, so, and it creates its own format. So uh, the standards are very, very essential, like how interchangeable data is used and how do you create common standards. Sometimes they come from an industry standard perspective, sometimes government impose, sometimes regulatory bodies impose those standards, but those standards are very essential so that we can have common utilization of data between systems. Again, those data interoperability with AI systems is also essential because that will help. Like if I have a common standard of data generation, usage, transformation, then all those things can be very, very easily adaptable to AI systems. AI systems expect data in certain kind of a format. If those formats are not meant, it will be very difficult for the AI system to correlate between different data elements which are generated and come up with some kind of predictive nature. I hope you're getting it, right? So that is very essential. So the third point is about interoperability of AI systems. That's where we are seeing that we are having a lot of AI connected systems, open environments, open architectures which can feed data and will impose standardization of data where all other systems should adhere to those kind of standard formats. Fourth point is about lack of skilled engineers. I will not talk about lack of AI ML skills, but I will talk about the lack of skilled people who have domain skills. Like imagine I am a domain expert in drives. I'm a domain expert in power electronics, right? But you know, a person who is already having the skill of power electronics and having the skill of AI, that combination is missing. You will get some computer engineer who know how to write AI algorithm, but he has no idea about how power systems works, how different types of drives are there, different types of electronic systems are there. So they have no idea about it. So a domain expertise is missing. If you see, like I can do like a demand forecasting of power in huge power grids, there are very, very expert people who have good understanding of how things would work. But when they complement their skills with the understanding of the new technology like AI and ML, they'll be able to make a great, I would say, like great combination. This is like a deadly combination. So you have a domain expertise and you also have the technical know-how of AI. That's like a deadly combination. Integration with existing infrastructure. So this is like the challenge, like how do we do integration? But you know, smart grid is one of the answer. We can also invest in upgrading the infrastructure for connecting with different systems and so on. So these are some of the case studies which I kind of collated specifically in the electric mobility area. You can also do some research on this, like how these systems, you can go, everything is one single case study. You will get from the internet that how Tesla's autopilot system is working, where it can have a lot of advanced driver assistance, it can have a semi-automated driving functions, lane changes or route mapping. All those things are there in Tesla's autopilot system. The Audi example which I was talking. So Audi AI traffic light information, that's where it is able to in real time determine the traffic light faces and predict the traffic signals and automate the driving patterns. BYD also have AI-powered battery optimization systems. If you see a lot of Chinese manufacturers, they are very, very heavy in the electric vehicles, and the reason they have got that edge is because of the battery manufacturing and battery optimization systems only. Right? So for a longer run drives, you need to have very powerful system which is managing battery and related electronics. So that's where you can look at the BYD's use case, and then you will be able to get more things like how they are managing battery health, charging, discharging life cycle, how do they use for extended life of batteries and so on. So that's a very interesting use case. Google's Waymo also have this self-driving technology. This is helping to have autonomous driving, and autonomous driving behaviors again comes into the lane changes, turnings and braking, acceleration and so on. And newest battery swapping service is also there. So this is helping us to design battery systems which can have longer, longer battery life, and then it can also have the swap facility when there is a discharge available. So that's also another interesting use case. Looking at some of the future trends, throughout these slides, I've spoken about multiple things, right? So we've covered from the smart grids to the EV propulsion systems to the battery management systems and so on. So this is like one single slider where, see, I'll share all these slides with the participants. So I'll share it with the professors, so they'll share it with you guys. So it's free to use. And then in this, you have, depending upon your expertise, right? So take one topic and then see, probably you can work along with your students, create a research project, publish a paper or whatever. So try to identify that. So integration of AI in EV manufacturing, AI-driven predictive maintenance. This is where there's a lot of work happening of predictive vehicle maintenance, automated driving tasks for advanced autonomous driving. That's the third one. Enhanced vehicle-to-grid communication. This is what I was talking about, regenerative braking, right? So where the technology is used where we can connect EV systems back to the grid and can pump in energy, and have personalized mobility solutions which will help us use your data, driving patterns. Every vehicle is connected with a controller. It will enhance. It will take the entire driving pattern, and then based on your driving behaviors, it can suggest a lot of things, right? So that's kind of new things coming up. And so final key takeaways, we are seeing that AI is here to stay. uh, AI, if complemented very well with uh, domain knowledge, essential domain knowledge. So that's where you guys are expert in. You have clear domain knowledge in the technology. So you might be experts in drives, you might be experts in power electronics, you might be experts in power systems and so on, or even deeper technology. But when you take those areas and identify how AI can complement that, so that will create a lot of advantage. We are seeing that there's a huge work happening in the vehicle EV side. We are seeing that there's a huge work happening in the battery management system. That's where there's a lot of traction in the coming years. I'm very positive that India is going to develop a lot of local EVs. At least we can, to some extent, probably we can import devices and then do a local manufacturing. But eventually, 10 years down the line, we are seeing that there will be huge influx of EVs, and there will be a lot of work, especially in these areas, like how do you do smarter EV manufacturing, or how do you do battery management and AI-based drive control systems and so on. So these are some of the key takeaways. And future is very bright. We are seeing that there's a lot of work there. And I would like to close with the thought that every time there is a new technology coming into play, people thought that it's going to be difficult for the existing workforce, but we have seen time and again that it is going to create lot many jobs, lot many opportunities, right? So it is going to challenge the status quo of human intelligence, right? For example, if you ask me, should a student in my college use AI or not? From one angle, we think that students should not use AI because it is trying to reduce the creativity of the student. It is trying to reduce the genuinity of the student and so on. But on the other angle, academicians are also fighting that students should use AI. We should create the exams in such a way that they are very complex. Even if they use AI, it will take a lot of time for them to crack. So we will going to see in the coming few years, I'm not saying 5 years, 10 years, in the coming 1-2 years only, we'll see that how the standard of education will rise, because now I can say that now you use ChatGPT, ABT, some BT, you use anything, but let us solve this problem. Can we create an optimized battery cooling system for this kind of a battery? And given 1 month of a time, you can solve it. And then you come up with a prototype, come up with the explanation, and so on. So such kind of things. So we are going to see that mankind is getting into a phase where we are going to solve bigger problems, not just coding a website. No, that's a norm. Probably 10, 20 years back, coding a website, creating a mobile app was something great. But now we are seeing that how engineering services coming very, very close with the use of technology, and how we can elevate the you know uh, human capability, right? Maybe like, currently it might take 10, 12, 15 hours to travel to US, but can I create a rocket system which can take in 1 hour, right? It might be very superfluous, or it might be something uh, may not be possible at this time, but the same thing happened over the centuries also, right? So like 150 years back, if I would have said that I will say hello now here, and somebody in US can hear me, then we could have told that that guy is an idiot, right? And maybe 100 years back, if I would have told that I will open a device like this, and then I'll click a button, and then I can see somebody in other part of India, 100 years back, if I would have told that, then people would have thought, is the same thing is happening. We are seeing that a lot of people are coming up with aspirational things of doing uh, higher things, and AI is going to help them to build. So I would think that this session was useful. If you want to connect with me, this is my LinkedIn. If you have LinkedIn, I would encourage everybody should have a LinkedIn account. Um, and I'll be happy to answer any questions you may have. I'll open up the floor for any questions on this topic. DBS, Development Bank, yeah.
AI is working with the banking sector.
Okay. So in banking, right, we have different, so the one which I'm working right now, so we've created a project where we don't have to have entire um, call center, entire call center is being replaced with the AI agents. Now what the AI agents will give, suppose I'm calling for my credit card. My credit card is having some extra charges or something. I have this call. So I call the credit card. Now agent will pick up. Agent will ask you question like, what is your name? What is your mobile number? What is your mother maiden name? All these things. Verify the user. Then it will ask like, what is the problem you have? Then you will explain that, I use the credit card. This is the first time I'm using the credit card. I don't know what these charges are. I don't want to use this. And this is not something I want. So this entire system, we are completely replaced with AI. So we are now having agents basically write the time you call get transcribed, transcription goes into the agent, agent will understand, agent will first get the information of the person. So call is happening, you are calling the call center, call is happening, the call center person is asking you a question, can you give me the account number, can you give me your mobile number, can you give me your date of birth? So this is happening, the call is happening, but at the same time my system is calling in the back end, verifying the user, coming back and hinting the call center agent that customer is verified. You understanding? And the call is happening. You are saying that I use this gold credit card, and this charges. I used it in September, and there are some additional charges which are levied. At the same time, the call goes in the backend, and there are system invocation happening where we are identifying why the charges happened, what is the reasoning, and the reasoning comes to the call center agent. Previously, you might have seen that they will say that please wait for a few minutes, I'll come back to you. Did it happen with anyone? Right? They will say that please wait for 5 minutes, excuse me for 5 minutes, I'll come back to you with some information. So that excuse excuse me, is not happening now. We are connecting all systems. Now, for example, we have a lot of AI jobs which run in the backend, which will tell should your credit card be upgraded or not. You are getting calls saying that, sir, your limit will be increased, maybe sometimes, or your limit will be decreased, or your interest rate is going to increase or decrease because of your usage and so on. So we have our AI jobs which are running in the backend, which will analyze the entire user patterns and then do a lot of recommendations. We call them as nudges, customer nudges. Now, all the customer nudges are coming in real time. When the customer care is talking, we can give the nudges. We can say that, okay, because your credit card is so and so, now you are eligible for the gold credit card, and this is, please accept, and then you'll get in. So every walk of customer engagement, we are trying to put AI agents, which now again you can say like probably you are reducing the call center agent's job, but probably this call center agent is much better than receiving calls, hello, aise hai aap, sab khairiyat, right? Instead of that, we're getting them into a better role and better capabilities. Did I answer that? Yes. Correct. Correct. Data audit, identifying whether it is the right data, genuine. Yeah. So again, if you take regulatory systems, specifically banking, insurance, maybe energy systems also, there are human in the loop for some mandatory applications. Yeah. But decision making. So you mean to say in this example also what I told, because banking is very highly regulated environment. Decision has to be taken by the human only at this moment, correct? So in the EV systems or in energy systems also, analysis will be done. Output of the analysis will be given to the human. Human is the one who has to use his or her knowledge, use the analysis done, and then come up with a decision making. So that kind of systems are there, depending upon whether it is a highly regulated or not. If it is not a highly regulated industry, decisions are being taken autonomously. Suppose retail systems, retail systems like recommendation of products or things like that. So you get in the DMart, you are getting coupon. Now coupon, because you are spending like regular spending, going purchasing dal, rice and so on, you will get a coupon for dal or rice. You're not getting coupon for utensils or clothes or electronic goods and so on. So non-regulated systems can use autonomous AI. Regulated systems where have a highly regulated, that's where the responsible AI come into play, that what data is being used, what transformation it is done to the data, what privacy levels are there for the data, and then what is the analysis that data is done, is it legitimate or not? And there will be a human in the loop who will be authenticating that. Right? Any other questions? I am not very expert, but yes, there is a use of AI also. But hyperloops are like for mass transformation and large volume transformation or faster transformation systems. Yeah. So I think they use this magnetic levitation and also the technology which helps. And especially I see in Japanese and Chinese related companies, we see a usage of hyperloops. There it can see like identification of friction or identification of magnetic strength or speed performance. So in those areas we can put AI, but again I am not expert in that, but this is some idea I'm kind of giving. Yes.
Japan. Recently, what happened in Lebanon? They used small amount of explosive in pages. Recently, Israel did one pager attack. We are importing these batteries from various companies, and it is a security threat also in future. And how to overcome from these challenges?
Yeah. So that's what it's happening right now. There is a trend change which you are seeing. First trend change is we need consumption. Important thing is consumption. If there is no consumption, then there is no even if you produce something, it will not be of use. So even if I want to set up a EV battery system within my country, or within, say, like Karnataka, I want to put a EV battery system, it will not go forward because there is no consumption. Government is now trying to identify how to increase the consumption of EV. So one part is that, okay, I'll say that I'll wait for 5 years to have my own battery systems, and then we'll have the consumption. Or we can say increase the consumption, do export, import of batteries, import of different parts, then do a uh, manufacturing. So we are in current that stage, but there is a lot of push towards getting these toolings, getting important things, specifically battery technology. That's what I was saying. In coming few years, we are going to see that a lot of battery technologies will be produced from India. Then the security threat will be there. But that till that time, yes, we have to bear with it. So if you see some of the manufacturers, right, of cars, so they will do thorough tests on the chemical component. They will do thorough tests on the testings of the battery, utilization of the battery from the importers. So that level of testing we can do, but we can't go beyond that. Very valid question. Any other question? I hope the session was interesting, right? At least, yeah.
Development came into micro level. AI is on micro level product. The unfortunately in our India, where they are missing, we are unable to get the AI into class. If I go like industry, any utilization of AI is very minimal. Don't know where they are missing because of large capital investment or technological gap or maybe mankind thought process is less here. Our experts are less here. I don't know. Utilization of AI is very less in India.
Yeah.
As per my knowledge, it is used in very high level, medium level, and micro level utilization. As you find out in China, any product.
Yeah.
Utilization of AI is there in even in less cost of 20 rupees product. Also, you can find out some AI software.
Right.
But in India, we couldn't find even our Indian mobiles also, because we have to import the AI mobile from. So that gap is very huge in India, medium and low level. So where could be the cause of AI? You are AI expert. What could be the cause we are unable to penetrate this AI today in the Indian system, where we are lagging because institutions are there, industries are there, personals are there, government is there, and people is there. So those mapping is missing.
Yeah.
To
So
find out the gap.
so this, I think this will get into a philosophy session if I get into the answer for that. But we Indians are still in a phase called as a survival phase, right? Uh, and we are more into service oriented nature. Over the centuries, we got into that kind of a mindset. The trend is changing. For example, if you ask any college student also what you want to do, his current our state of mind is still in a survival. When we need innovation to be done, we need to let go of things like, will I get a job? Will my company survive? So imagine he starts a startup. So now the government is doing some funding, right, to some extent and some level. We don't have a heavy research funding. Countries like US and China, Israel, we are seeing that they are heavy into the AI and so on, and they have huge funding from industry, there's huge funding from government, and the mindset of people is also that they are not job oriented, right? If you ask any of your students, if I ask anybody of us, right, we still have that thought that, I need to get a job, I need to get a paycheck, I need to take care of my family. Of course, we are getting into the state we call as survival state, right? So we are getting from a survival into something called as a pleasure state, right? Some people are fortunate, they probably, if you're kids, like kids, I see a few of them, their parents were in survival state, right? Because they were like going to some, maybe they might be bankers, they might be maybe farmers, they might be doing some private job and so on. We are seeing that lacking right now. So that's the reason it's very, very essential, especially for academic institutions, to instill a level of innovation and a level of the daring nature, right? So entrepreneurship, we are seeing different governments are providing that kind of facilities, providing some kind of funding for coming up with the products. So eventually, I am very positive that in another 10 years, maybe 15 years, we will be seeing that kind of a trend change. Because if you see nowadays kids, right, they are not worried about the survival problem, right? They're not thinking about, I'm not getting roti this afternoon, what will I eat tomorrow? Did they ever complain that what will I eat tomorrow? They never such kind of thing. But our parents are having that kind of a problem. Eventually, these kids, now if I take kids who are currently in 10 years, 15 years, when these guys grow, they will have enough cushion to do innovation, enough cushion to do research, enough daring to set up enterprises, even if they are failures or not, doesn't matter. So that's when, this will go into a philosophical thing, like why it happened to India. Because of course, again, we are very positive, right? We have like 140 crore population, and median age is around 29 years, Indian population. So there will be so many people in 10 years who are the working population. And then so many people are there, there are so many jobs, so much work. We can do it, but that mindset has to change a little bit. I personally believe that a lot of work has to be done, both academia, industry, to instill that kind of a daring nature in students, not getting into the survival rat race mode. So that's my thought. Hope it can't be solved. It's a very philosophical, it's like a deep rooted problem. Eventually time will solve. No, but they started almost 30, 40 years back.
What they have done 50 years back, now
We are doing.
we
Yeah.
are doing.
Yeah.
That is a gap we have.
We have almost 20, 30 years gap.
30 years gap.
But we can speed it up. Uh, Again, our industries, we have everything is service industry. Computers also, we are not creating anything, right? We are not creating the Amazons of the world. We are not creating the Googles of the world. We are serving the Amazons and Googles of the world. Right? So that's the change. The reason is that. So I think it will take time. All right. So I think I'm already in between your lunch. So I hope this was a good session, hopefully. And thank you very much. Thank you. Thank you.
Thank you. We did a that we have done when it comes to AI. I would be there in my work and solidly. So after this session, your electrical vehicle, types of electrical vehicle, what is the structure of electrical. So you calculate this, even hard copies also you have required. Ultimately, there are four articles you should have to identify. First article is relevant to the basics. What is the electrical vehicle, structure, and understanding of its basics. So 1, 2, 3, 4. Even some experts who are coming in coming days, they will use their article, they will do. And at final day, as a team of 4, 5 members, you have to submit one article summary, what you understood from that article. So that's why we are circulating these articles, which are very much important for the business. So ultimately, we need a one summary report from 4, 5 members as a one. You make it your group, it's okay. Otherwise, our members will make you as a group. And one small report you have to be submitted to us to upload to AICTE. So that's the value of your evaluation based on that. So now to calculate this one, please go ahead when you have lunch time and basics only, these are not that much. Basic details of electrical vehicle, particularly the structure and types of electrical vehicle, literature review paper. Now identify. Then record one is for article. Quite often. Soft copy is for us enough because we have to upload only. Whatever one summary statement, your name with the title of summary article, summary report. Just send it us. We'll give you mail ID. Just submit us to because make sure your name should be there in any batch because you have to upload to everything folder. Ultimately, your name. Ultimately, we need a batch-wise report. That report has to be submitted back to us, and we'll submit to AICTE. This is a very basic exercise for one of the evaluation components. At the end, last day. MCQ is also there. MCQ, as I briefing I given, there are 4, 5 components. One is article summary, and there is one a project which we have today's and tomorrow's session afternoon. A small MATLAB project is put in front. Anyhow, he will help you with that. And this one, and at the end, last, you will have assessment of 20 minutes or 15 minutes, which is the questions given by expert, and feedback, which you have to fill in your ATAL portal. You have to fill the feedback, and this is mandatory. After the feedback only, after fulfilling all these, your certificate will be generated in your AICTE portal. So certificate whole and soul, the AICTE is only provided with the fulfillment of all the